Let's take a look at some derivatives, simple derivative rules. I'm going to look at the product rule, the chain rule, and the quotient rule, but first let's take a look at what's called the power rule, and this is pretty much the easiest or most basic derivative rule that you'll learn first. So let's say we have a polynomial here, x cubed minus 2x squared plus 4 root x, and we want to find the first derivative of that. Remember, the first derivative is just the slope, and so we're going to change this here to exponent form. That's going to be 4x to the 1/2. Right? And so the power rule states that in order to find the first derivative, we take that exponent, we just drop it down, and that becomes a coefficient, and then we reduce that exponent by 1. Okay? So 3x cubed turns into 3x squared. 2 times 2, we have to multiply the leading coefficient by the exponent there, so 2 times 2 is 4. And then we reduce that exponent by 1 power. We don't need to write first. And then here we have 1/2 as our actual exponent, although here it's written as a root. So we're going to take 1/2, multiply it by 4, we get 2. And we're also going to subtract 1/2 for 1/2, we get negative 1/2. Remember from our rules of exponents, and that equals 3x squared minus 4x. If we have a negative exponent, then we can write that as 1 over that exponent. So here we have 2 on top. 2 over root x, or 2 over x to the 1/2. That's the power rule. Let's take a look at application of the product rule next. So I have an example here. Number 2. Say 625 minus x squared raised to the power of the 1/2, or we could write it in a square root sign. Sometimes if it's in a square root sign, it could be a little bit tricky. You might not recognize it as a power, right? And then all of this is multiplied by x to the 1/2. So we could also write this as root 625 minus x squared all times root x. Okay, so the first thing we want to do with those square roots is write it in an exponent form. And although this might not look like it, this is actually a compound function as well, because inside of our square root sign we have 625 minus x squared, which is the difference of squares. 625 is a perfect square of 25, and then x squared is a perfect square of x. And so this here is actually equal to 25 plus x times 25 minus x, if you remember from factoring. And so what we have to do here is apply also the chain rule. We have, again, a compound function. We have f of g of x, right? So we have a function inside of a larger function. So this is kind of a tricky one, trick question. What we have to do here is find first, put a little a. First, let's find the derivative of that there. So we're going to apply the chain rule. So first we have to find the derivative of the outer function, which is, we'll call all of this y, or z, or q, or p, or whatever. And so all of that, b, is raised to 1/2. And so the first derivative using the power rule of b to the 1/2 would be 1/2 b to the negative 1/2. And so we could say this is all u to the 1/2. Right? And so we have 1/2 u, which is 625, minus x squared, and that's raised to the negative 1/2. Okay, so there's our first part, and then we also want to find the derivative of the inside function, right? So what is u? U is 625 minus x squared. All of our constants will turn to 0 when we find the first derivative, so we're left with negative 2x there. So all of this is times negative 2x. All right, and then we could simplify this by saying this is equal to negative 2x over 2 times the square root of 625 minus x squared, and then we could drop these terms here. We end up getting negative x over 625 minus x squared. Okay, so let's find the second part. We're going to apply the product rule now. That means we're going to take our 1/2 x to the minus 1/2, that's this part here, and we're going to multiply that. So we've got, in our product rule, f of x times g of x. We've got f of x times g of x. Doesn't matter which is f of x, which is g of x here. So we're going to take g of x, f of x times the first derivative of g of x, and we're going to add to that the first derivative of f of x times g of x. So I've taken the first derivative of this one, multiply that by square root of 625. 625 minus x squared. And then we're going to add to that x to the 1/2, sorry for mixing square roots in exponent form, times what we already found here, which is the first derivative of that negative x over square root of 625 minus x squared. And so we can further do the algebra here. This equals square root of 625 minus x squared over 2 root x. Right, so x to the negative 1/2 is 1 over root x. We have 1 over root 2 root x, excuse me. We're adding to that. We've got a root x on top here. We're going to multiply that by a negative x. And on the bottom we have a square root 625 minus x squared. Completing for 625 minus x squared over 2 root x minus x root x over square root 625 minus x squared. Alright, so let's get ourselves a little bit more room here. Quotient rule. So again, the quotient rule is the first derivative of a quotient is f primed of x, g of x, minus f of x, g primed of x, all over g of x squared. Let's take a look at a simple example. 3. So we have x cubed divided by x cubed minus 5x plus 10. And so we have two simple functions. We're just going to take the first derivative of this top part here, 3x squared, and multiply that by the bottom part, x cubed minus 5x plus 10. Not enough room up top. (3x squared times x cubed minus 5x plus 10). Subtract from that the top part times the first derivative of the second, so we'll drop down our exponent, turn it into a coefficient. Remember, our constant turns to 0, and our single x term turns into a constant. And on the bottom we have x cubed minus 5x plus 10 squared, which equals x to the 6th minus 5x to the 4th plus 10x cubed minus 5x to the 4th plus 25x squared minus 50x plus 10x cubed minus 50x plus 100. All right, looks pretty messy there. So let's simplify. On the top, we end up getting negative 10x cubed plus 30x, and that is all over x to the 6th minus 10x to the 4th plus 20x cubed plus 25x squared minus 100x plus 100. And we can factor the top part a little bit. We get negative 10x times x squared minus 3 all over that big messy bottom part, x to the 6th. And we could probably factor this a little bit, but that is a pretty complicated situation to take care of by hand right now. And in the end, we might not be able to factor it, so we'll just leave it as it is. Okay, there's our simplified answer. Take a look at one more example for the chain rule. Okay, so we have number 4 here. Let's try x cubed plus 4, all raised to the power of 5, and that is over 3x to the 4th minus 5. And so we've got f of g of x over h of x. This is the chain rule and the quotient rule. Sorry, f of g of x over h of x here. Right, so let's figure this out. We've got, first we'll take the derivative of the outer function. So we've got 5 times x cubed plus 4. I'm going to multiply that by the derivative of the inside, which is 3x squared. Remember that constant turns to 0. Let's put this all in parentheses like that. Then we've got that times derivative of the inner function. We're going to subtract from that for our quotient rule. The first top function there, x cubed plus 4 raised to the power of 5 multiplied by the derivative of the bottom. 3 times 4 is 12. We'll drop that exponent by 1. And then that's all times 3x to the 4th minus 5 squared. Continue with the algebra, which might be the trickiest part here. As long as you get those product rule, quotient rule, and chain rule, a lot of times the algebra is the trickiest part. So we've got 15x squared times 3x to the 4th minus 5. Maybe we multiplied 5 by 3 to get 15 here. We've got that times this here. And we're going to multiply that again by x cubed, which should be to the 4th. X cubed plus 4 raised to the power of 4. Subtracting from that 12x cubed times x cubed plus 4 raised to the power of 4. Notice we have the same term here, so we're going to be able to factor that top part. And we've got 3x to the 4th minus 5 squared on the bottom. Let's factor that top part. So we've got all of this times this minus this here times this. And what we get is, let's take out a 3. Common factor between 15 and 12 is 3. So we're going to take out 3x squared. We're going to leave an x cubed and a 4 here. We're going to leave a 5 here. So we've got that times x cubed minus 5 raised to the power of 4. And that's all times 5 times 3x to the 4th minus 5 minus 4x times x cubed plus 4. And I notice I made a little error here. Sorry about that. Should be a 5. Okay, and that again is all over the bottom part squared, which is 3x to the 4th minus 5 squared. Again, just continue with the algebra. 3x squared times x cubed plus 4 raised to the power of 4 times, multiply this out, we get 15x to the 4th minus 25 minus 4x to the 4th minus 16x. And finally, all of that is over, let's call it g of x squared. Finally, we get 3x squared, times x cubed plus 4 raised to the 4th times 11x to the 4th minus 25 minus 16x all over 3x to the 4th minus 5 quantity squared. So going back to that first slide here, these are best to just memorize. Product rule, quotient rule, and chain rule. As long as you recognize what's a product, what's a chain, and what's a quotient, the power rule will usually also apply and derivatives become a lot easier.